All right. Next in our notes, oh, my pen is not connecting, so that's cool. If two lines are parallel and cut by a transversal, then there are special relationships in the angle pairs that are formed by those lines. So there we go, let's get that. Parallel and cut by a transversal, and there are special relationships in the angle pairs that are formed by the lines. So we learned in the last video about the names of those angle pairs. Now we're going to find out what happens when those lines are parallel. If those lines are parallel, what happens? So when those lines are parallel, and down below, your notes look a little bit different than mine. I've drawn in this guy on each of those. So you can go ahead, if you like your highlighter and notability, you can highlight some of those angle pairs. But let's look. Okay, corresponding angles. So theorem 3.14, corresponding angles theorem, and these are the professional terms for them. This is a mathematical theorem, and in proofs you could actually write theorem 3.14, but in your notes I've actually written the actual ALEKS proofs, like what they write in ALEKS for them too, the verbiage they use there too. But if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So let's look at what that means. Up here, the corresponding angles, so like 1 and 3, those were corresponding angles. Well, if our lines are parallel, those lines are going to be the same size, or those angles are going to be the same size. They're congruent now. So if this one is 100 degrees, this one is also 100 degrees. Okay? So not only do they have that name corresponding angles, but now they have that knowledge that they are congruent. Okay? Now we also know that 2 and 4 are congruent. Oh, sorry, I was going to go with colors. Here we go, highlight. 2 and 4 are congruent. 7 and 5 are congruent. And 8 and 6 are congruent. All of them. Okay? And if you look down below, it says in ALEKS proofs, when you're doing the proofs and you look at the drop down, you'll be looking for one that says, if lines are parallel, then corresponding angles are congruent. So what that means is that you might be given a proof that says that this line, you know, line L and line M, so it might say line L is parallel to line M, and then in your proof, you'd be able to write, well, then that means that angle 1 is congruent to angle 3. And your reason would be, if lines are parallel, then corresponding angles are congruent. Okay? So in that box, that's your reason that you could use in ALEKS. Okay? All right. Next, alternate interior angles theorem. So this one, if those lines are parallel, all alternate interior angles are congruent also. So that's pretty exciting. That means that angle 2 and angle 6 are going to be congruent. So if you're loving the highlighting, you can be highlighting those, or you could be marking them. You could be marking them that this one is congruent to this one. And that 7 and 3 are congruent. There's your alternate interiors. Okay. And there's your ALEKS line too. If lines are parallel, then alternate interior angles are congruent. And for consecutive interiors, those ones are going to be supplementary. They're going to add to 180. Remember, that means add to 180 degrees. So when you see 2 and 3, those ones add to 180. And 7 and 6, those add to 180. There you go. Okay. Alternate exterior angles theorem. All alternate exterior angles will be congruent when lines are parallel. So 1 and 5 will be congruent, and 8 and 4 will be congruent. Okay. And on your sheet, yep, and in mine it says, there is one more theorem, Theorem 318, that says, in a plane, if a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. And I don't have a drawing for that, but it's pretty easy to draw out. So if you've got two parallel lines, there we go, and they are parallel to each other. And then we've got a transversal here. And it's perpendicular to one of those lines. It will also be perpendicular to the other. That's pretty obvious. Yep. That would have been also proven true by the corresponding angles theorem, because corresponding angles are congruent. Okay. So this particular theorem is not an ALEKS. So we don't use that to prove in proofs. So you can make a note that it's not an ALEKS. You don't need to memorize it. You won't have to use it on tests. Not on your test. Okay. All right, let's move on. So in this example, cross ties I and K are parallel. So as soon as you see that, are parallel, we're going to go over to our diagram and we're going to put little marks on there showing that they're parallel. I'm going to put little drawing there. Both cross ties are intersected by H, so let's pay attention to H. Here it is, H. There. Measure of angle 1 is 42 degrees. I'm going to write that in, 42 degrees. My black pen is really hard to read. I might go grab a pink. I think that might show up better, 42. Find the measure of angle 7. So 7 is down here. So if I look at that, redraw it, I've got, that's I. And K. I have H coming down through it. I'm not going to make it look 90 degrees because they did not tell me 90 degrees. There's H. Angle 1 is up here, and they tell me that's 42 degrees. And 7 is down here. I could write in all the rest of the numbers. I'm not going to draw in J because they didn't talk about it. Not worth my time. What I need to ask myself is what angle pair is 1 and 7? And so I think back to my rules before. They're on the outside, which means they are exterior. And they're on opposite sides of the transversal, which means they are alternate exterior angles. And then I'm going to go look up at my rules, and alternate exterior angles are congruent. So that means that angle 1 is congruent to angle 7, which also means that the measure of angle 1 is equal to the measure of angle 7. Oh, and I shouldn't have an equals or a congruent sign on top there. Oops. So that means that the measure of angle 7 is equal to 42 degrees. All right. Hopefully that made sense. All right, that's what they're going to go ahead and write that. And they wrote it out like a proof. And now you go ahead and try that one. Pause me. come back and check it. Did you get 62 degrees? Hope so. Okay, let's go on to number 3. Use the figure to find the value of the indicated variable. Okay, so they want to know if measure of angle 3 is 4x plus 7 and 6 is 5x minus 13, find x. And they tell us that these are parallel. Good. Well, these angles are on the interior and they are alternate, and alternate interiors are congruent. That means that angle 3 is congruent to angle 6, which means that the measure of angle 3 is equal to the measure of angle 6. So that means I can set them equal. 4x plus 7 equals 5x minus 13. So I can solve. I'm going to subtract my 4x and add my 13. So x is going to equal 20. Okay. There it is, x equals 20. Good. Okay, and then they say, I'll go up here. Now they say y, if measure of 8 equals 68 degrees, and measure of angle 3 equals 3y minus 2. Okay, well that's going to be a little bit more confusing because we don't have a relationship between this one and this one. So we're going to have to play around a little bit with that. What should we do? Well, we can do a few things. We do know that these two are vertical angles, or these two are vertical angles. We could do either one. So if I go ahead and I'm going to draw it a little bit bigger, if this is 68, I can make this one 68 also. And then this is 3y minus 2. Then these two have a relationship. Those are consecutive interior. And those are supplementary. Okay. Okay, so if I know that, that means the measure of angle 5 plus the measure of angle 3 will equal 180. So I'm going to add those together. 68 plus 3y minus 2 equals 180. And I subtract my 2 from, I simplify on this side, so I get 66 plus 3y equals 180. Then I'm going to subtract my 66. And I get 3y equals 114. And what do I get when I divide 114 by 3y? Goodness. Where's my calculator? Well, my calculator does not want to open. So we're just going to go down and find out. Nope. $38. There's y. Okay.